Hello everyone. Hello everyone. Today we shall discuss right angle triangles and Pythagoras property. Pythagoras, a Greek philosopher of 6th century BC, is said to have found a very important and useful property of right angle triangles given in this section. The property is here named after him. In fact, this property was known to people of many other countries too. The Indian mathematician Bodhayan has also given an equivalent form of this property. We now try to explain the Pythagoras property. In right angle triangle, the sides have some special names. The side opposite the right angle is called the hypotenuse. This is AC is hypotenuse. And the other two sides are known as legs of the right angle triangle. AB and BC are the legs. Or can also it said to be BC as the base and AB as the perpendicular. In triangle ABC 6.23, the right angle is at B here. So AC is the hypotenuse, AB and BC are the legs of triangle ABC. Make 8 identical copies of right angle triangle of any size you prefer. For example, you make a right angle triangle whose hypotenuse is A and units long and lengths of and legs are of B units and C units. Draw two identical squares on a sheet with its length B plus C. Here we have written two squares B plus C. This side is B plus C, this side is B plus C, this side is B plus C, this side is also B plus C. You have to place 4 triangles in one square and the remaining 4 triangles are in the other shown in the following diagram. In this way, the 4 triangles will be here 1, 2, 3, 4, right? And here also 1, 2, 3, 4, right? Here you see that means the uncovered area will be same as the uncovered area here because square A and square B has the same size, right? Therefore, the area of uncovered area of this area and this area will be same, right? The squares are identical. The 8 triangles inserted are also identical. Hence, uncovered area of square A is equal to uncovered area of square B. Area of inner square of square A is a square, that is A into A, that is A square. The total area of uncovered squares in square B, here is, so see, this area is B square and this area is C square, that is A square equal to B square plus C square. This is Pythagoras property. It may be stated as follows. In right angle triangle, the square on the hypotenuse is equal to sum of the squares on the legs. Pythagoras property is very useful tool in mathematics. It is formally proved as a theorem in later classes. You should clear about its meaning. It says that for any right angle triangle, the area of the squares on the hypotenuse is equal to the sum of the areas on the squares of the squares on the legs. Draw a right angle triangle preferably on a square sheet, construct squares on its sides, compute the area of these squares and verify the theorem practically. If we have right angle triangle, the Pythagoras property holds. If the Pythagoras property holds for some triangle, will the triangle be right angle? That is yes. We will try to answer this, but now we will show if there is a triangle such that the sum of the squares on the two of its sides is equal to the square of the third side, it must be right angle. It must be a right angle triangle. The opposite is also true. Here, do things. Have cuts of squares with sides 4 cm and 5 cm and 6 cm long. Arrange to get a triangular shape by placing the corners of a square suitably as shown in the figure. Here, this is square, and this is square. Measure each angle of the triangle. You will find that there is no right angle at all. You will find that there is no right angle at all. In fact, in this case, each angle will be acute. Note that 4 square plus 5 square is not equal to 6 square and 5 square plus 6 square is not equal to 4 square and 6 square plus 4 square is not equal to 5 square. Right? Repeat the above activity with squares whose sides have length 4 cm, 5 cm, 7 cm. In this case also 4 square plus 5 square not equal to 7 square. This shows that Pythagoras property holds if and only if the triangle is right angled. Hence we get this fact that if the Pythagoras property holds, the triangle must be right angled. Here also you can find the various values by using Pythagoras property, right? Here this is 3, this is 4, this is 8, this is hypotenuse. Since this is 90 degree, you can write according to Pythagoras theorem that x square is equal to 3 square plus 4 square. Here also x square is equal to 6 square plus 8 square. Here x square is equal to 15 square plus 8 square. In this way, you can find the value of this also, that x square is equal to 7 square plus 24 square, and in this way you can also find that this is the, if you find this value, that means this value hypotenuse is given, therefore 37 square minus 12 square you will get this value, and 37 square minus 12 square you will get this value, and if you add the value you will get the total value of x. Here also you see this is this one. This is but this is 90 degree, then means 5 square minus 3 square you will get the value of this one, and 12 square minus 3 square you get the value of this one, and if you add this one you will get the value of x, right? In the next video we will solve the exercises. Dear friends, what you have to remember that if the Pythagoras property holds, the triangle must be right angle, right? And if the triangle is right angle, then you can apply the Pythagoras theorem also. What you have to remember that in a right angle triangle, the square on the hypotenuse is equal to sum of the squares on the legs, right? This is the Pythagoras property or theory. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.